Hey YouTube, it is quarter after 1 on Wednesday, May the 18th. Yep, that's right, May the 18th. And I just wanted to do an update on some cluster earthquakes that I've been noticing. One of the things that I like about this Google Earth here is you can actually go on the USGS website and grab a KML overlay, and it'll give you the earthquakes, of course, by magnitude and the size of the circles, as well as red shows stuff that happened in the past hour, orange for the past day, yellow for the past week. So it's really only giving you the quick snapshot of what's happened. But as you zoom in, you can see, oh, it looks like something just happened in that Hawthorne area in the last hour. Actually, just a couple minutes ago, they got hit with a 3.5 Nevada. That's that same Hawthorne area, but it's nice. You can actually see these little clusters. So if you haven't seen this before, it is a handy thing. You can go to the USGS website, and all you have to do is click on the left side where it says KML RSS feeds and data, and that'll bring up a couple of lists, and this M1 plus earthquakes for the past 7 days. And I like the top one. It gives it to it by age rather than just by depth. And anyways, that's what I'm looking at when you see these little dots. I find it's better sometimes than the earthquake that you can click on from the gallery, because a lot of the times it gives you, you know, all the earthquakes. This one back in 1934. Well, I don't really find that to be specific to a cluster that's happening now. So again, I like that sometimes better than that earthquake overlay. So what I wanted to know here was noted. I keep referring to him, but Dutch is the man. So anyways, in one of the previous ones, he'd noted if you're noticing earthquake clusters, look around and see, is there some kind of activity that's going on? Do you notice drilling, especially if you're looking in like Google Earth or something, you know? And if I go back into that cluster that's happening in Nevada, which is just outside of Hawthorne, you know, they've been having this going on for a while now, quite a few of them. And unfortunately, you know, the more you go in and you look around, I can't find anything that relates to, you know, drilling, or is there some kind of ore processing going on. You know, there's some things, but you can't really see it there. So I've been looking at that. The other thing that I use for looking at where clusters are happening is the previous video I just did shows that I've been tracking all the information from the USGS, plotting into Excel. And I quite like that. And of course, California is probably the hot area. It typically always is, as well as Alaska. If you saw that previous video, you'd understand how I came up with this information. But it's plotted weekly, and each week I can see how many earthquakes are happening per each area. So, you know, California is always the high one. And I thought, well, why don't I take a peek and see what really is going on in California? So this is just a full list. I've been taking this list since March the 27th. It's been 49 days since March 27th, and there's been 6,000 quakes in the U.S., in North America, say. And what I noticed was a lot of these are all around the same area. We've got a bunch around the geysers, a bunch around the geysers. So if I actually just filter out and look at California, there's been 2,500 earthquakes in California. If I do a filter on location and just look at, I just want to see all of the ones that contain the word geysers, just because it seems to be an area that that's quite high. So there's quite a few. There's 416 out of those, all happening around the geysers. And this is from the earthquake list off the USGS, and it and it will show everything from a 1.0 and greater. So, you know, you do get a lot of the 1s and 1.3s and all, but, you know, we've got our 2.6s and 2.4s. It's not just the tiny ones. They've got some, you know, substantial ones. And if I look at this magnitude list, because I filtered out by state and then by the word geyser in there, I can see that, you know, yeah, there's been 3.9, 3.4, 3.3, 3.2, quite a few. So, of course, going back to the Google Earth then, this is one thing I noticed. That Excel spreadsheet just gave me a little bit further information. But I'd already noticed it because as I'm looking around, and I like to look for clusters, and I've got on the Google Earth, it actually shows the all the different plate boundaries as well as some of the major fault lines. So what you see going from this green line here, if you can see it, this will be in high def, but hopefully you'll be able to see it. There's the line that runs all the way down through here, which is of course the San Andreas Fault, and you'll always have earthquakes along that area. These ones aren't specifically right on the fault line. You get a couple that follow the clusters. I don't really see any in that Hayward fault as a typical thing. And again, these are only earthquakes happening in the last 7 days. You know, if I plug on that earthquake list, that should light the map up pretty good. So again, you know, those are typical. They're going to happen on the faults. But I noticed this cluster happening up here. Let me take this off. And I couldn't figure out what the heck this was. So I wanted to follow again Dutch's info and say, well, go look for some kind of activity that's going on there. And I noticed as I go in, it's like, okay, well, there are things going on here. I'm going to actually put that earthquakes back on because it helps you see activity. I mean, that's a lot of little earthquakes going on. And they're not just tiny, you know, 3.4, 3.7, 3.5, some other ones, little ones and things like that. But, you know, as you look in on this area, it is covered with these plants. And I didn't understand what the heck was going on with these. So hopefully that'll zoom in and you'll be able to see it. There's plants, and then there's these massive pipes that run everywhere. And you know, you go to try and follow one, and then all of a sudden it zigs off and goes to another one. And these pipes, if you can see these pipes, it's taking a while to refresh because I got too many things running. These pipes run across the roads, they run down, they follow the roads, go off on some weird pump here. They just litter this mountain area. So I tried to figure out exactly where these all lead to, where they go, and where they come from, because they're right in all of this area of earthquakes. Now, if you can't see these little red dots, just throw the, you know, the gallery view on of earthquakes yourself and take a peek, because it really is, you know, it kind of gave me one of those aha moments. So I looked and I tried to follow the pipe, and as you follow one pipe, it leads you off somewhere else. I couldn't tell where I'd been, what I'd done, and what I'd looked at. And so, wow, these go all the way down. So it seemed like this is where it ended and this is where it started. And I couldn't see any more piping going past certain areas. So again, this is a big plant, and they've got the piping that runs off here. Oh, there's more piping that runs there. And again, these are roads. You know, branches off this way, branches off here, but it terminates here. It doesn't go any farther, and there's a big well right here. So, and again, that's where the earthquakes ended. So I thought, I'm going to actually start trying to figure out where do all those pipes go and where do they run. And in Google Earth, you can just, of course, hit one of the path points, and you can click and you can add a path and change the color and style. And you know, it's a point and click one where you do this and it follows, which was perfect for what I wanted to do here. So I created one, and I just called it Geothermal, and you just see I just clicked that one little add point on there, and it made a pipe, the line that I followed of the pipe. So from here, this set of piping comes out, and I just copied the little waypoints and went, okay, and bang, it ends here, where there's, you know, looks like some well heads. Which I thought, okay, that's interesting. And it helped me because, again, these start to spaghetti off all over the place. And as I click on, you know, each of these, you see that, oh, okay, yeah, that one went off to there. And I clicked on another one, oh, okay, that went off to there. And they are surrounding a lot of these earthquake areas. So I kept going through and doing this and came up with, you know, and I'm starting to zoom out here, just a ton of these pipes that went all through the mountain ranges, which was quite shocking to see once I actually finished, going through and looking, because I'm down at ground level there where I'm looking. It's the only way to follow these pipes. And when you actually start adding them all on, it was one of those holy crap moments. Now, somebody like Scott or Dutch or anybody that does any kind of earthquake and geothermal or seismic information, I'd be curious on your thoughts on this, and you'll know why in a sec. So again, this is a pretty big area. I'm just going to keep putting those on, and you'll see them as they start to fill in. I did this mapping. It took me a couple of days because some of those lines that I'm making are quite long, and you really had to follow through to see where exactly they all went to, and to make sure I didn't miss any branches going off anywhere. So I had made 76 of these control paths, and there are still more up here that I don't think I've actually gotten to. And again, you look at all those red snakes going across there, and they just intersect every one of these earthquake zones where they've had, well, looking at my list, this list here was only from the 27th of March, and they've had 416 quakes in 49 days. So I thought, okay, that's pretty crazy when you start looking at some of these and you realize, I didn't do anything funky or different here. I just, wherever a pipe went, I followed the pipeline, and some of them kind of disappear. They actually put them underneath the roads, and they'll come up again, and you can barely see the pipe in there, but it took me a while to find them all, and where they come through and end and terminate. Some of them a little easier to see, and then bang, goes to a plant, and off of that plant it goes to somewhere else. So again, it's pretty crazy as you start backing out and realizing, this plant is freaking huge. Look at all the spaghetti of these pipelines that run everywhere, and theyese are big pipelines. They're not tiny, especially when you're zooming in. So I think I got most of them. Again, I'm quite far out here, but I realized as I'm going in now, I wanted to see, it was kind of tough to find some of these. You had to almost look for an area that was a bare patch and go, okay, oh, did I miss one there? And no, okay, that's a bit of a hydro substation, so that's not one that I missed. But you do see all these bald areas that they're starting to, and if that refreshes, they've leveled it, cleared it, made a path to the road, made branches off in the mountain area that go off to another patch. So it's basically, they're just expanding. You can tell that exactly. This one, they've got a little bit of a man-made lake in here, more areas ready for the piping. I did think that I'd gotten it all, and then it's like you think it terminates. Here's one last station, and these are the trailers of semis here, so you can tell, this isn't tiny. And as I go up here, where I thought that there was another one, this is actually a really large well. Dudes pick up trucks. It's a good size facility. But I did notice, unfortunately, as I started looking into other areas, I have actually missed some further up in the mountain. There's another one I didn't mark at all. I've flipped on every one of my little geothermal control points, and you can see here's all this piping. I'm going to have to go map and see where it goes. And that one terminates right there. But here's another site right here that they're getting ready for. This other pipe starts coming down through the bottom here, goes to another set of these wells. Anyways, that's just a frustration because that is quite a distance off from the end of this chain, so that means they're going to be pumping that all the way through there. So pretty freaky when you see all that. Okay, I gotta try and speed this up here so it's not a half-hour vid. Took me forever to find this. I couldn't figure out who ran this, what it was. This was the very bottom one. Sorry, I keep going in and out, but this is where the earthquakes terminated in that cluster. If you look way out, You know, they're not really any farther there. That's just all, these are all clustered around there, all in May and March. And so the only thing I found was, while looking at all of these, I found this one power plant, and thankfully they did this, and they put it on the roof, NCPA. That just gave me the beginning of where I started to go. So doing a few searches for that, what you basically come up to is, this is the Northern California Power Agency, which makes sense. That is Northern California. That's up in the Geysers geothermal field, and I should have put that together anyways when I noticed all those in the earthquake list I was maintaining, but essentially that's what it is. It is a geothermal facility. Now, first thing I gotta say is, geothermal energy on its own, I think, is a good thing. You know, for businesses and for homes, people that just want to tap into some geothermal heat or energy to be able to reduce the amount of energy that they need for their heating costs and all that, and it's and the impact they have on their energy consumption. I think that's a good thing. However, when you get big business and power companies just looking at a way to generate profit from the earth without taking into account the full impact on the earth, that's wrong, and it's basically should be considered criminal. And you'll see why when I start speaking about this. This is, I'll put all the links below because I got a lot of quick ones I want to go through. You really have to go through and dig in this Northern California Power Agency. To me, their site speaks exactly as what you would have seen from the gas and shale companies when they talked about the fracking there. This is just an example. I want to come back down to this page here, but you know, powering the future, woohoo! It's good. It's good for us. You know, we're all good, and yay! Look at how well we're doing. So that's this little red square is where we were just looking, and that's the Geysers geothermal project. You know, there's some good things about it, but there's some real nasty things about it too. This is the world's largest geothermal field. They actually produce, I think, 2/3 of the U.S.'s geothermal megawatts coming out of there. So they're producing 2,043 total megawatts. The one thing I wanted to note in here was, I'll get you to go through and read this stuff. Yeah, the Geysers is the largest geothermal field in the world. As in the case with all geothermal sites, the original steam supply in the Geysers geothermal reservoir has gradually depleted over time. Well, they've been doing this for 25 years, so yeah, they basically sucked that one dry. To extend the resource life of the underground reservoir, the NCPA, Northern California Power Agency, has proactively developed new sources of water for injection to create additional steam. So one of the things that they did in 2002, they entered into a partnership with nearby Lake County to pump treated wastewater up the mountain and inject it into the reservoirs. And it prolongs the life. You know, it's solved they say it's a win-win, you know. Again, that's why I think this is just like the shale and gas industry, you know, fluff marketing, saying, hey, you know, we're helping the community by, we've got a place to dump their local wastewater. And I'm sure the treatment on it isn't like they're going to go grab a cup out of the thing. This is, you know, secondary cleaning. It's not good cleaning. Anyways, I'm not going to go too much in that. You can find these information in links below. Another one, again, same thing. Look at the clean skies and all this. I am happy I found the area that they actually put up this little solar array to help power one of the pump stations. This right now says that 5% of the state's energy needs are supplied by this area, this geothermal thing. It covers 30 square miles in those mountains, and 60% of the entire northern coastal region's electrical needs could be met through the electricity produced at the geysers each year. Yeah, you really have to go through this. I honestly think this is the next fracking. One thing about the that you can take a quick peek in Wikipedia and understand what geothermal electricity is. The one thing is it's not totally clean. It says right here the emission intensity of existing geothermal electrical plants is 122 kilograms of CO2 per megawatt hour. It's about an eighth of conventional coal-fired plants. Well, you know, that's great, but it's still contributing to greenhouse gases and to heating of the planet. The one thing there, if they're generating 122 kilograms of CO2 per megawatt hour, well, that previous little propaganda page they had here showed that they were producing 2,043 megawatts. Well, 122 kilograms of CO2 per megawatt hour means that they're producing a 250,000 kilograms of CO2 per year. So that's one thing. There's a lot of good information in here if you want to know a little bit more about geothermal electricity and how it's produced. You know, they basically drill into the ground to replace the it's two pipes. One's going to pump in water and one's going to extract steam. So the one thing here is there is an environmental impact, and essentially, try and be quick on it, but fluids drawn from the deep earth carry a mixture of gases, notably CO2, hydrogen sulfide, methane, ammonia, and these pollutants contribute to global warming, acid rain, and noxious smells. Existing geothermal electric plants, just what I said there, emit an average of 122 kilos per megawatt hour, which is a small fraction compared to fossil fuel plants. Agreed. Totally agree with that. One thing that they say here is plant construction can adversely affect stability, land stability. Subsidence has occurred in the Werraki field in New Zealand. Enhanced geothermal systems can trigger earthquakes as part of hydraulic fracturing. The project in Basel, Switzerland was suspended because more than 10,000 seismic events measuring up to 3.4 on the Richter scale occurred over the first 6 days of water injection. You know, when I look at Google Earth and I see that kind of activity around an area of geothermal production, that's huge, and they're expanding further up this way, and the earthquake magnitudes that they've had for those ones went as high as a 3.9, so those are getting to be bigger earthquakes. Anyways, AltaRock, I'll come down to this page here. This is just another link I found on geothermity, but it was just an evaluation report of a whole bunch of different areas, and the basically on the increase of induced seismicity and the seismic hazards and risks. I'm going to go back to that area. It was page 3.3 where it just spoke of the geysers, and the Geysers geothermal area is a site of vapor-dominated steam field from which electric power has been generated since the early 60s. Earthquakes are concentrated at the steam production field and extend about 6 kilometers down. Actually, if I look at this one, most of these are only a couple of kilometers in depth, so very close to the surface. Some of the other ones are even less than that. They're right at the surface. So prior to the onset of power production, the region surrounding the geysers was characterized by a very low level of seismicity, albeit seismographic coverage was poor. Yeah, it was the 60s. But this group here, the Ebert, Phillips, and Oppenheimer in 1984, suggested there are two plausible mechanisms that may explain the induced seismicity at the geysers. One, the volumetric contraction due to mass withdrawal. So in other words, they're sucking all that steam and pressure out of the ground, which could perturb the stress field and cause faulting in the reservoir rock, already near failure or due to regional stress field. And two, the aseismic deformation due to regional tectonism may be converted to strict slip deformation due to an increase in the coefficient of friction along the fault surfaces. How about it's because of the water and chemicals you're injecting into the fault lines? That's probably a bigger issue. Yeah, it's going to happen, but you're not going to have it. You know, again, they even said themselves, it was a very low level of seismicity, and that's not all low level of seismicity, especially when you start zooming in and you really see the extent of all these little earthquakes. Especially if I take off all my red lines so you can see them. You know, that's a lot of earthquakes. Anyways, I'm making this really long. Another quick one I found, quake threat leads to Swiss to close the geothermal project. And this is that one they were talking about in Basel, Switzerland. It was shut down permanently. This was in December 2009. Their $60 million project was shelved because the study determined that earthquakes generated by the project were likely to do millions of dollars in damage each year. You know, to me, doing this kind of crap, and I call it crap because that's what it's doing. I mean, as you zoom out, you lose some of those smaller earthquakes. But when you see that, this is almost as asinine and stupid as putting the power plants in Japan. You're doing these right along a fault. It's close enough. And say goodbye to California when that finally slips and cracks and breaks. And, you know, clean power. Woohoo! So this is a good article as well, but basically for them it generated thousands of quakes once they started doing that. Goes on to talk about the AltaRock project, which is another project. This one down here, the AltaRock project, is the Obama administration's first major test of advanced geothermal energy. And like the Basel project, AltaRock's plan is to drill miles underground, fracture the hot bedrock, and circulate water through it to generate steam. So let me see. Go in there, crack the earth, fill it full of water, and let's hope some steam comes out. Yeah, steam's going to come out, but then it's just going to freaking fracture even more. Fricken-Frack. Anyways, read on this. Last link I'll put into my vid as well is that at least the Nature one here, their weekly journal of science, they put this out. This was actually a little while ago as well, probably around that same time as that other story. Geothermal quake risks must be faced. They really do. They need to look at this stuff before just going and saying and drilling in. I can understand, again, geothermal energy, not the electricity where they're, you know, pumping water into the ground and sucking out steam. You know, go collect the cow's farts if that's what you want to do, but don't be destroying the earth to make a profit. I don't see that as right. The one last thing I noticed while doing this Google Earth, and I love my little, you know, research and tool here of Google Earth, is I'd noticed, again, I was looking at these clusters, and the one thing I noticed was there was quite a few of these clusters happening around this the southern tip of Mexico here. And what I realized was, yeah, there's all of these little quakes here, and I couldn't figure what the hell this blue thing was. So as I go and I look at this blue thing, that's a pretty funky looking thing. I realized that's some kind of water, and realized that it's, you know, something that the water, dirty water, goes around and around and around and finally comes out, looks like somewhat cleaner water. And then realized that, you know, there's this channel of water that runs around and through, and then realized, holy crap, it's just another one of these frickin' fracking water plants that has miles and miles of pipe going all over the place, doing their geothermal, generating something from the earth here without understanding the impacts on what they're doing. So anyways, hopefully this will get the same effect that fracking did, because this isn't a great, clean, renewable resource. Not with the chemicals they put into the ground, the way they destroy the ground to get it out. And yeah, that's enough of me. Alright folks, stay safe, and let me know if you find other information. I'll keep putting these ones out. Thanks.